Hello, welcome back. So we're almost at the end. I talked about SPARQL server engines, open source, commercial cloud solutions. So the open source version that is probably best known and that will also work with in the lab exercise is Apache Jenner. Apache Jenner is a general framework for all kinds of semantic web, RDF, knowledge graph related technology. And one sub-project is Apache Jenner Fuseki, which is the SPARQL server. Essentially, you need two parts. First, you need a way to store the triples. And this is done with another sub-project in Apache. This is TDB. So this is what's known as a triple store. It's essentially a database that stores all the triples. And then on top of it, you have Fuseki, which is a server that takes SPARQL queries and delivers them using the SPARQL protocol. So we'll work with this in the lab. If you like, you can already try out to install it. You need Java to run it, but then you interact with it using either the web-based interface or by sending HTTP requests. So you can start a server. Once you start the server, you can either load RDF data to it, and you can create multiple data sets, and then you can query them. And you'll see a query interface that looks somewhat similar to the one that you've used for the DBpedia exercises on the worksheet. And then you can run the query and see the output, select which output type you want, and so on. So again, this is something we'll try out in the lab, and then later it's going to be part of your project work for storing your knowledge graph that you develop. Finally, the last topic for today is again looking at something we discussed before. Remember, I told you when you have a triple like this, you have a student that's a subclass of person, and then you have a concrete instance, Joe is a student, and you put this into your knowledge graph and you run a SPARQL query, and you want to know all the persons in your graph. And you run this, and if this were a live class, I would ask what's the result. And then what typically happens is that some people say you must get Joe back. And then I ask why. And well, this is what we talked about. Joe is a student. Every student is a person. So using inference, you can know that Joe must be a person. But when you try it out, you'll be disappointed to see that this is not what's happening. You will simply get an empty result. Why do you get an empty result? Because by itself, you will match exactly the triples that are in the triple store. And there is no triple in the triple store that says Joe is a person. You have a triple that Joe is a student, and you have a second triple student is a subclass of person. And the triple pattern Joe is a person doesn't exist by itself. So this inferencing step is something that you have to take care of in one of multiple ways. Essentially, what you need to add is reasoning support, inference support to your system. And the way you can do it is you can add inferencing support to your knowledge base, to the triple store. Then what will happen is that it will materialize all the triples using these inference rules that I discussed. And then when you run a SPARQL query, all these other triples will be materialized, meaning there will be in the triple store, there will be a triple, Joe is a person, and then you will find it in the query. The other option is that you have a inference supported query engine. So you have to connect the query engine together with a reasoner. And there are different types of reasoners because there are different types of languages. So here we talked about RDFS mostly. So this is what you need here. You need an RDFS reasoner. But earlier today, I also showed you the OWL language. And I told you that it has a lot more complex logical expressions. So for dealing with OWL construct, you would need a different reasoner. You would need an OWL reasoner. And they are significantly more complicated than RDFS reasoners. So what you can do then is to combine the SPARQL query engine with a reasoning engine. And then you can retrieve these additional patterns as well. But this is an extra step for setting up. You have to have not only the triple store and the SPARQL query engine, you also need an additional reasoner, and you have to connect it in one way with either the triple store or the query engine. So for now, don't worry about it too much. This is just to explain you why when you run a query like the one shown here, you're not getting the result that you expect. There is an additional setup step for doing inferencing. But in the first lab exercises, we're not going to look at that because we're first going to set up the basic infrastructure, making sure everything else works. All right, you made it to the end of today's lecture. What do you have to read? Well, you have to read something about SPARQL. It doesn't really matter which of the references you read. This is in the book that I mentioned before that you can download, this developer's guide. So it has a chapter on SPARQL, but that's not the only possible reference. One that's very nice is the one shown here, which is this book, Learning SPARQL. So this is a whole book just about SPARQL. And you should be able to access the book online as well using the Safari Books online interface. Another nice reference, not so long, to get a quick overview is chapter 5 in this book here, which is this linked data book. We're also going to use this book in the lecture next week. So for a quick overview, you can read the SPARQL overview on the World Wide Web Consortium website. This is a very nice chapter, and this is also a good chapter. And if you want to, at any point, look up more details, this is a very nice book to get more explanations and examples about SPARQL. Now, obviously, you have a lot more details in a whole book than in a single chapter. So simply look at those, which ones you like best, pick one of them, and in the lab exercises, I'm also giving you a few more online references. That's it for this time. Like always, please post your solutions on the worksheet form on Moodle, and I will see you again next week. Bye-bye.